Okay, continuing on with auroras then. We have now an established fact from physics that says as follows here. An electric current makes a magnetic field, period, because we saw those filings move outside of that wire when we made the electric current turn on. So what does that have to do with the Earth? Well, it sort of works like this. Let's draw the Earth here like this. Here's the Earth, the blue planet. Here's the equator. There's the North Pole. There's the South Pole. Yes, it's tilted. I'm not going to worry about that right now. And of course, as you know, what's very important about this step of logic also here is that the Earth spins. And it's a relatively fast spin, I guess. 1 time per day, right? 24 hours. So the whole Earth spins once every 24 hours. And, well, so what? Well, here's the so what. It turns out that you may know this also from geology or maybe a physical science class, that if you go to the interior of the Earth here, where the core is, the core basically is a bunch of hot lava down there. And it's so hot that any molecules down there of any material, whether it's iron or silicon or whatever it is, can't really hold on to its electrons. And so what you have down in the core there then is a bunch of positive negatives, all just sort of swimming around there in the lava. So here's the core here, and it's hot lava. It's not solid is what I'm saying here. It's definitely molten. And so all these charges are just sort of swimming around in there. But the next piece of the puzzle then is that, okay, so you have this hot core here, which is sort of like a big liquid in there. But nothing like water, again, just liquid lava, bad stuff, bad hot stuff going on. But of course the Earth is spinning. But because the Earth is spinning, it's going to make sense that the core is going to be spinning also. So I'll draw this again, but I'll get these positive and negative charges a little bit more organized now to illustrate our point. So here's the blue Earth again here. There's the equator, North and South Pole. The Earth is spinning like this. And if I come back in here now and draw the core in there with all those charges in there, then what happens is, I guess I'll draw this in green because I drew the charges in green up here. So I'll go back to green here. It turns out that all those charges are sort of going to be sloshing around in the same direction as the spin. So what I'm trying to draw here is if I get in here with a bunch of positive and negative charges, let's just say over here, the charges will slosh and spin with the rest of the Earth. So it's not like there's something special about the core, like the core is spinning all by itself or anything. It's like you, me, and everything on the Earth is spinning, and so is the core. The core is spinning with the rest of the Earth, and that means these charges are spinning in here too. But now you think about it, in our step of our logic here, well, what is all this then? What is this down in here? Well, if the charges are spinning, then these are moving charges. Moving charges, okay? Because they're moving. The charges are moving because the Earth is spinning. Now let me go back up here a little bit, back to sort of our logics and things that we were drawing here. We said when a current flows, a magnetic field is produced. I might have even started that. Here we go. Yeah, electric current makes a magnetic field. Okay, so now you think a bit more in here. I'll come back to that diagram in just a second here, but you think a bit more in here about what is a current. Well, a current are moving charges. So when I showed you that light bulb example, the circuit earlier, the wires kind of look like this. And there's these little blue balls in there, which were the electrons that maybe sort of look like this. And these electrons then, when the current flows, these electrons move through the wire. So moving charges make a current, but a current makes a magnetic field. So here's more of the logic here. Moving charges, well, that's exactly what a current is. But then as we also discussed, a current makes a magnetic field. So what you can kind of do in this example here is you can kind of in terms of the Earth and astronomy, you can kind of just sort of skip this step here and go, hey, look, if I've got a bunch of moving charges, I must have a magnetic field. This is the logic here that's definitely worthy of some pause and review in here, because this sets us up then to understand why the solar wind doesn't kill us and why we have auroras. So we'll get that going in the next video.